long, it affects the strength of the instrument, and the top will start to sink over time. So all these things make a difference. They also have to be wide enough to get the sound post in. So we have limitations on that, but if it's too wide, it makes it weak. And here's trimming up the Fs. We primarily use a knife after the rough cutting with a saw. And we always finish all these things, even though we've drawn the shape on, we always finish these things up by eye, because the eye can show much more, will see much more detail than you will with a line. A line is for a rough shape, rough idea. There's measuring the thicknesses. This is a modern tool. The one that Strad used was basically a pincher, kind of just did this. It would lock in place. He could read over here where it had a little gauge that said what that thickness was. We now have these which are marked in tenths of millimeters, which is what we do thicknesses to tenth of millimeter. To assist in that, I use a tool that I built that puts a small pinprick on the inside of the instrument. Rather than sitting there measuring cut, measuring cut, measuring cut, I put these little teeny pinpricks to the depth that I want to go, so that when I carve it with the finger planes, I'll know how deep to go. So what this is right here, there's a little point right here, and we just push that down into the wood, and it puts a little pinprick, these little pinpricks right there, and then I can carve down until those are gone. Another thing we use are what we call tap tones. You heard the piece of wood earlier vibrate when I clunked it together. Well, you can also take a piece of wood and hold it and tap it and hear that frequency. I'm going to attempt to see if we can hear that through the microphone. I'm not sure if you'll be able to. Different pitches there. They're actually the same pitch, but they're an octave apart. They're both C's, by the way. If you can't hear it, the other way to do it is to use a modern conveyance, which is to take a speaker, a tone generator, and put a frequency through it and allow the piece of wood to vibrate. We then put glitter on the piece of wood, and it forms these different shapes. And that's something that was basically discovered in the 70s by a group called the Cactus Society, very apropos. And they are still in existence today doing research on instrument making and tonal characteristics. I've done this, but I don't really prefer it to sound. Since I can hear the pitches, I do it that way. You also can test the flexibility of the piece of wood, and sometimes you have to make the piece of wood thinner because it's too rigid, even though the thicknesses are going to be less than what you anticipated it to be. This is just an example of the thicknesses. These are all in millimeters. You can see it goes from 2.5 up to about 4.5, depending on the location of the spot. The sound post area, the center of the instrument, is always going to be the thickest. The bass bar, as I mentioned before, is a piece of wood that runs the length, almost the length of the inside of the instrument. It strengthens the top, it evens out the tone, the way the instrument vibrates, and it's used to support the bass side of the bridge. Here's the bass bar glued in, ready to be finished, trimmed, and tuned. And yes, we tune it. We actually test the sound prior to gluing it in, and then glue the bass bar in, cut it down, and we want that tap tone to be the same note once we glued it back in again. Then the instrument starts to get put together. The back is glued on. The form is removed. The upper linings are now installed. We weren't able to put them in because they wouldn't be able to get the form out. There is a method of doing that, but it's a little bit more involved, where the form actually collapses and pulls out in pieces. But this is what most of the time is being done. Linings are trimmed down and smoothed over, and then the top is glued on. Then we do the neck. The neck again is a piece of maple, and we make it to the right width, and then trace the pattern on. These patterns are just made out of an old for sale sign, by the way. That's why you have these red stripes on it. That was the lettering and all that. It's cheap, it's easy. Here is the scroll cut out. And then we make some lines that are the width of the fingerboard here, and then trim down to where the scroll actually starts. We make a lot of cuts all the way around the scroll. And this is so that we can easily take small pieces off to be able to create these curves. Otherwise, it'd be really hard with just a chisel to start hacking out at it. So we cut these ways, and then we cut across here, taking out all these little triangle bits. And these are the tools that we use. Once we're done with the saw, these are the gouges that we use to cut all the way around all these curves. They're different sizes and different curves based on the area that they're working. And this is one of the larger tools used in one of the bigger areas. And we're just kind of roughing out the first turn here. And you can see where that flat facet from the saw was. Right there. And then again, we scrape things smooth once we get to that point. And this is the cut's all final, and the wood smooth. The back of the scroll also needs to be curved. It's what we call fluting. So that's done next. Then we lay out the shape of the neck joint using the fingerboard, which is right here. We draw on the shape of the mortise. There are basically certain parameters that you have. You have the width here, you have the length, which is determined by the height of your ribs, the height of the sides, plus a little bit of an overhang that the neck is above the top of the instrument. So this is a known distance, and this is a known distance. So with that, you can lay it all out. And then a mortise, a recess is cut into the ribs to receive that. There's a lot of different angles that go on here. You have to have the height, you have to have right and left, you have to have depth, just lots of different things to keep track of as you're working and fitting those pieces of wood. And you can see here it's basically ready to glue in, and this is drawn here as to the cut. This was left thick so that I wouldn't be short any wood when I got to that point. And so this is trimmed, and then the neck is rounded. Once the neck is glued in, then we finish up and round over the edges. This is done this way so that in all this previous work and moving things around, we didn't put any ding marks in it and damage our edge before we get to the point where we want to make everything clean and getting ready to finish the instrument. And once it's all smooth and rounded over and everything's scraped and clean, we get ready for a varnish. The preparation of the wood is basically the scraping and cleaning, making sure there aren't any dirty marks on it. Then we seal the wood, and we put a ground color on the wood. We use a spirit or an oil varnish. Two different things. The spirit varnish is an alcohol-based varnish. An oil varnish is an oil-based varnish, basically a turpentine. There are two different schools of thought. Some people use spirit, some people use oil. I prefer oil. Oil is what was used by the Italian makers in the 1500s through the early 1700s. The number of coats will be determined by what kind of varnish, but anywhere from 6 to 15 coats. Alcohol varnish is going to have more because they're thinner. And then we layer the colors onto the wood. We don't just do one color, bam, it's done. You never put the color directly on the wood because it'll be very uneven. And you don't get with the layering of color, you don't get the flat version like you get with most furniture. You get a very depth, it almost looks 3D as you're looking. Here's the sealant coat going on. I just use a shellac, and it's just until it stops soaking into the wood. And here's some final varnishing color. Actually, it's just a clear coat at this point because the color is all on. You'll see I did something what we call antiquing here. You have a little lighter area here, which is kind of a natural wear. Over 100 years, you get wear of varnish, and so you'd have a little lighter color. A lot of musicians like an antiqued violin. They like instruments to look old when they're new. Unfortunately, it's what sells instruments. Stradivari has never antiqued his. He did it the natural way. Of course, he also sold to kings, so he didn't have to. And lastly, once the varnish is dry, which can take anywhere from 2 weeks to 2 months to varnish an instrument, again depending on the number of coats and the type of varnish. Oil dries much slower than alcohol. Alcohol varnish can be varnished again the next day. Oil sometimes 2 weeks between coats. So then we have to glue the fingerboard on. We have to do the pegs, sound post, cut a bridge. The end pin, tailpiece, and chin rest have to be added, and of course we have to put the strings on. Here we are gluing the fingerboard on. Fitting the pegs. You will see that this is a taper tool. It's got blades on it. We also have the shaper for the pegs, which is basically akin to a pencil sharpener, old-fashioned little hand pencil sharpeners. Those have to match exactly or the pegs won't stick well. A lot of cheap instruments don't have very good fitting pegs, and so you have a lot of frustrated players, especially these poor kids, when they get an inexpensive instrument where it just won't stay in tune. It's usually because of the pegs. Here is that sound post. Right here you can see it on the inside of the instrument. It's standing up. It's basically a dowel about 1/4 inch in diameter. It sits, the top of it sits right here behind the bridge, and it can be moved in, out, treble bass, and each way affects the sound. Moving it this way makes it brighter, that way makes it darker. This way gives you a faster response when it's closer to the bridge, back, a slower response. But no instrument's ever that easy. Pretty much have to play it, adjust it, play it, adjust it. Sometimes you have to fit 2 or 3 sound posts until you get it to be exactly what you want. Here is a view through the bottom of the instrument, looking at the sound post. You can see it standing straight up there. We can see peeking right there is the bass bar. This is the block that the neck is set into. Here's your linings. Of course, there's your ribs, and that's the top, that's the back. This is just a blank that we throw on there. I mean, it comes as a blank, then it has to be cut and fit to the specific instrument. The feet have to be cut to fit the top of the instrument to the exact shape. And all the different parts of the bridge, the top, the arms, the waist, the ankles, all have to be adjusted to different thicknesses and to tonal characteristics. Again, sometimes I cut 2 or 3 bridges before I get one that I'm satisfied with. And then we install the strings and set it up and tune it up. And there's a finished instrument. It's actually a viola. I just changed the slide. That's the viola that I made last year at IRCC. And that's the basic way violins are made. Somebody asked me why do Strads cost what they cost and so forth. I mentioned a little bit about that, but they also do sound incredibly well, most of them. Again, secrets of sound. If you have an extremely well-made instrument, it's played well, it's kept in good condition, and 300 years later, it's going to sound good. We have great great makers today making instruments. That if you were to put them behind a curtain and you were to get 100 people with Hal's ear to be able to assess the quality of the sound, you would probably say 50-50, old instrument, new instrument, with the quality makers that we have today making instruments. Now, we don't know what those instruments are going to sound like in 300 years. Hopefully they'll be at least as good as they are today. But there are a lot of great makers today, as were in the past. There were a lot of very fast violins made that just never did sound good, either because they were too thick, they used wood that was treated, as in chemically treated, or they thought they had the secret to Stradivarius, and they tried this, they tried that. But basically the violin is pretty much unchanged in the way we do it, and the basic concept. We have a little bit more physics behind us today, but it's basically unchanged.
Are they all hand done? All
No,
instruments?
no.
Can they be mass produced?
They are mass produced, but you won't get the sound quality. You can find violin on eBay, on Amazon, $50, but it's going to be pretty awful. Generally, I tell people that if you're a beginning student, don't bother unless you can spend at least $350, because, as I mentioned before about the pegs, these $50, $100, $150 instruments are just set up with the most awful parts, and they don't fit, and you'll spend another $150, $200 making it playable, and it's still going to be a $100 violin because it wasn't made very well. The materials are awful. They were kiln dried because they can't wait 5 years to use wood. They cut it, they kiln dry it, they use it. The varnishes are sprayed on lacquers, which are much too hard for violins. They're great for beginning students because they take a lot of abuse. I'm not saying don't go out and spend $10,000 for a fifth grader, but